All right, lesson 4.7, the last one in the unit. We're going to form a function of one variable from a verbal description and, when appropriate, determine maximum and minimum values of the function. Okay, so for this lesson, you're going to need some geometric formulas, distance formula, which we've studied this year, areas of two-dimensional figures, okay, maybe triangles, squares, rectangles, trapezoids, perimeter figures, and the lengths of special right triangles. Okay, so recall your 45, 45, 90 right triangle. The legs of the right triangle are equivalent, and the hypotenuse is x root 2. And then in a 30, 60, 90 special right triangle, opposite the 30-degree angle is the short side. The hypotenuse is 2 times the short side, and then the side opposite the 60-degree angle is x root 3. Okay, you can prove either of those using the Pythagorean theorem, that is in fact what the relationship for the sides are. Okay, for these, read the problem. Draw a diagram if possible. Write down the information you know. Write down the function in terms of the variable needed. That's the goal. So you want to be able to write your function in terms of one variable only. All right, first example, express the area of a circle as a function of its circumference. Okay, so we start with the area of a circle. Area equals pi r squared. Now we want it as a function of its circumference. So we want the area of a circle in terms of its circumference. Okay, so C is going to be the variable in the equation. All right, so recall what the circumference is. Circumference is pi times diameter, or we can think of it as 2 pi r. So we're only allowed to have the variable C in the area formula. So when I think of area is equal to pi r squared. So how are we going to get rid of the radius? Well, let me go to my circumference equation and solve it for r. Dividing both sides by 2 pi gives me now an expression for my radius in terms of my circumference. So then replacing r in my area formula, okay, so I'm going to take this and I'm going to replace it with r, circumference divided by 2 pi, and then I have to make sure that I square that because that's what the area formula tells me to do. All right, so now let's simplify this. Area in terms of the circumference is pi times square the numerator and square the denominator. All right, so I'm going to do that one simplification, dividing out the pi. So I would have circumference squared divided by 4 pi. So that's my area in terms of the circumference only, meaning the circumference is the only variable allowed in the equation. All right, so now express the circumference as a function of the area. All right, so I have area equals c squared over 4 pi. So now solving this equation for c, first I'm going to multiply both sides of the equation by 4 pi. And then when I take the square root of both sides, circumference can't be negative, so I don't need my plus or minus out front. My circumference will be square root of 4 is 2. So it'll be 2 times the square root of pi times the area. All right, suppose P is a point on the line x minus 3y equals 5. Express the distance from the origin to some point P as a function of the y coordinate only. All right, so if we think of a sketch, x minus 5 equals 3y, dividing both sides by 3. So if I think about this line, y-intercept just a little bit below -1 with a slope of 1/3. So it's going to be an increasing line. Okay, so point P is somewhere on the line. We don't know where it is, nor do we care what it is. Okay, it could be up here. It could be down there. It could even be something like the y or the x-intercept. Express the distance from the origin to that point P. So we're going anywhere on the line to the origin. All right, so here's our distance formula. Distance equals the square root of the difference in our x coordinates squared plus the difference in our y coordinates squared. All right, our distance formula, we can think of it from the Pythagorean theorem. So now I'm going from point P, which has coordinates x comma y, to the origin, and the origin is the point 0, 0. So my distance is going to be x minus 0 quantity squared plus y minus 0 quantity squared. Okay, x and y are the coordinates of P, 0 the coordinates of the origin. Now I want it in terms of the y coordinate only. So what do I have to eliminate my distance equation? I have to get rid of x. So if I go back to my original, x minus 3y equals 5. Solving this equation for x, I get 5 plus 3y. And now I have x in terms of y. So into my equation, I'm going to replace x with 5 plus 3y. Now, we know x minus 0 is just x, so I'm going to combine a step here. Okay. So I have distance equals square root of the x squared plus y squared. Now, I am going to make you expand this and simplify it. So now notice my distance only has one variable in it, the y coordinate. That's what the question asks, but the next part does ask you to maximize or minimize it. So let's sort of do a little bit of side work here and simplify this. Squaring a binomial, square the first term, double the product of the two terms, square the last term, and I have to add to that y squared. So my distance in terms of y, 10y squared plus 30y plus 25. So that's the answer to part A. Now for part B, find the minimum distance D and the point P associated with this minimum distance. Okay, so here's our distance, 10y squared plus 30y plus 25. My distance will be a minimum, so my distance in terms of y will be a minimum when this function underneath is a minimum. Okay, well, this function isn't new to us. It's a quadratic. Now, hopefully this is seeming familiar from when we did the optimization problems also. So if I'm looking to minimize a quadratic function, the minimum just comes from the vertex. So my vertex, negative b all over 2a. So that gives me negative 3/2, but be careful here. That's my y coordinate, okay? Now this is a parabola. A is equal to 1. It opens up, so I know my vertex is going to be a minimum. So I'm going to first find the point P, because it'll be easier to find the distance then. Okay, so if I have my y coordinate to find my x coordinate, remember our relationship for x in terms of y. So we know that x is equal to 5 plus 3y, right? That's from our original equation here. So my x coordinate will be 5 plus 3 times my y coordinate. So I get 5 minus 9/2, and that gives me an x coordinate of 1/2. So the answer to the first part, my coordinates of point P will be 1/2 comma negative 3/2. Now remember what you were asked to do. You were asked to find the distance from this point to the origin. So if I go back to my distance formula being x minus 0 squared plus y minus 0 squared, I think this is easier than substituting the y value into our distance formula in terms of y. So I would get 1/2 squared plus negative 3/2 squared. So complete that for homework. Find what the distance is equal to. Okay, so simplify that for us. All right, next example. An open top box with a square base is to be constructed from sheet metal in such a way that the completed box is to be made of 2 square meters of sheet metal. Express the volume of the box as a function of the base width. Okay, so open top box, square base. So I know in a square, all my sides are the same. So S and S, Sorry all, but this is the best figure you're getting. Okay, so I want my volume in terms of my base width. I picked the variable for my base width to be S. All right, in a three-dimensional figure, my sides are equal. I'll call this the length. That's the distance between the sides. Now, granted, it's open top. It's an open top, so we'll just call that the base. Okay, so I know that my volume is area of the base times the height of the figure. So my volume in terms of S and L would be S squared times L. We have to eliminate L somehow, okay? Eliminating L comes from this piece of information. So think about what 2 square meters would give you. When our units are squared, that's our area. So if I'm creating this figure from 2 square meters, that's my surface area. Okay, so check out our figure. Our surface area is the area of the base. It's a square. Area is side squared. Plus the area of my lateral faces, those non-base sides. Because it's a square, all of these lateral faces have the same area. And that's S times L. And then there's 4 of them. So 4SL. Okay, now substituting in what I know, the surface area is equal to 2. Okay, so this number came from our given piece of information. And now I need to solve this for L, right? Because I need to eliminate L because the question is asking me for volume in terms of S only. So I'm going to subtract S squared and then divide by 4S. So that'll give me L in terms of S. Now I take this information and I'm going to plug it into my volume equation. So volume is side squared times 2 minus side squared all over 4 times S. Okay, one simple simplification. Now I am going to distribute that S. My volume in terms of S, 2S minus S cubed all divided by 4. So this would be my final answer. Okay, we'll finish the video here. Please make sure you complete the previous example and find the distance.